Hello, everyone, and welcome back to our online TestConf spring edition. This is Joel, and back from our break. I want to introduce our next speaker. His name is Bede and Ngaruko. Bede, did I say your last name correctly? Please help me out.
That's correct.
Okay, so Bede and Ngaruko is here, and Bede is going to be talking about the testing challenges in the highly interconnected world of IoT. But let me just give you a couple of pointers about Bede because, by the way, Bede, you can start sharing your screen if you want at any time. So Bede is an automation engineer working for Medic Mobile, and he's based in Auckland, New Zealand. If you do the math, it's 5:15 a.m. for him right now. So guys, if anything, just a round of applause for the fact that he's up so early. He has been working on a large range of applications and apps in multiple environments, and he will share with us a lot of the experience of multiple years actually in testing automation. Finally, Bede is also the founder and the organizer of the Automated Testing Auckland Meetup. That's correct, right?
Yeah, that's correct. Yeah.
So just a reminder to everyone, if you want to ask any questions, you can either do it from the Q&A or, as most people are doing it lately, via the Slack channels. And send us your pictures, and Bede, the floor is yours.
Thanks, Joel. Thanks, Mayan. Thanks for everyone involved and everyone online attending this conference. As Joel mentioned, my name is Bede. On LinkedIn if you want to join, also on Twitter, not very active, but my name is there. Today I'm going to talk about a subject I'm very passionate about, but that I found very challenging when it comes to testing, called the IoT, or Internet of Things. It's a pity that I cannot see you guys and ask you to raise hands, but I wanted to know if there is anyone involved in IoT. You still can raise your hands here, or anyone doing electronics systems as the part of their testing. And the point I want to make is, if you're doing
by the way, Bede, we can actually ask using the Zoom application. People can raise their hands. So guys, if you're doing IoT or electronic testing, go ahead and raise your hands.
Yeah, that's great.
Yeah, we actually have that feature here, man.
Yeah, I saw that. Yeah.
Give me a second. I'm counting people. So far, we have, again, a bunch of people actually doing it.
Okay, great. So if you're doing electronics, well, IoT is probably a new term, and if you're doing electronics, you are most probably doing IoT, because nowadays most of the electronic systems we do have got some sort of back-end connection to the internet, and that's really what IoT would be, and we're going to see that in a bit. So what is IoT actually, this new thing called the Internet of Things? I'm not very good at definitions, but if you go out there and look for what IoT is, you find these terms like interconnected physical devices, like vehicles and the building, things like smart devices or embedded electronics, software will come in there. And that's where we most probably fit in as a software testers, sensors and actuators, which are more of physical part of the system, and the network connectivity, which is the internet part of things. Obviously, the point of connecting all these devices is just to collect data or to exchange data among the devices. So what are those things? Statistics at the moment, or predictions, say that normally we will have more than 26 billion devices by 2020. That's quite a number of devices out there connected together to the internet. And those include our normal wearables that we most probably are aware of, smartphones that we probably have got at the moment, tablets as well, some sensors for industrial applications or home automations and stuff like that. Health devices are becoming popular as well, starting by small wearables for individual health, but also for large applications in hospitals and health centers. We've got cars now. They are coming online with the driverless cars coming pretty soon or already into production as we speak. Planes as well. And as I said, they are all collecting data for analytics or for some other commercial use. And that's happening in real time. And I think that's pretty much where the challenge is when it comes to testing those devices in real time. So a typical IoT architecture will look like this, where we've got the things themselves that I named in my previous slide. And we've got the internet, which is connecting them all together, but we also have got the middle tier, which may be a web app, a web service, a web API, and we've got the database, of course. But this is just really in a nutshell. Otherwise, we've got the cloud. Maybe the database is on the cloud. We've got a lot of other things in between here, but these are the main parts of the IoT system in general. And we have got a lot of users already at the moment, such as data management on devices, transportation is being used now, management, sharing data, etc., etc. And in the industry, it is being used in industry at the moment. Smart homes are becoming very popular. Smart city is also something that is becoming extremely popular. And I remember now that we're speaking that actually one city in Israel is becoming smart, probably the first smart city in the world at the moment. I think it's Israel or something. I mean Jerusalem or something. And health and the fitness, etc., etc. Am I correct, Joel? Is that happening? I saw that in an article last week.
If it was to be, it would definitely not be Jerusalem.
Yeah.
But I think that it might be Beersheba as one of the cities that are aiming to be automated on multiple levels. Yes.
Interesting to see how it pins out.
Well, you can always come. My aunt actually lives there, so it's okay.
Great. One of the things, this screen is just mind-boggling. It's just too confusing. It's too overpopulated, and I just got it from the internet. And I don't want anyone to think or to pretend that I know anything about this one. It's just, I just put it there to show how complex the system is. This is to show how much we've got to deal with. All of these things, or this system has to be tested somehow, one way or another. And you can see that it's just too hard even to comprehend the building blocks that we have there. And I'm not going to go through this. As I said, it's just too much of it. But the point is, this screen, I didn't make it. I found it out of the net as it is. And that shows really how big and how confusing the picture looks like in the future as far as Internet of Things goes. We have one interesting application I've seen in Rwanda, which is a small country in East Africa, where drones actually are working to just fly saving blood supplies to clinics in rural areas, remote areas, which is really a very interesting application done by Zipline, a small San Francisco-based startup. It's quite a very interesting application of IoT systems. So the challenges are multiple, but the first challenge is about the things themselves. And those things are, as I name them, composed of hardware, like the car. We've got some like the air conditioning unit. We have like refrigerated trucks. We have like home security systems, including cameras and proximity sensors and all other sensors, alarm system and stuff. So those are hardware stuff that we're not necessarily familiar with as software testers. So that's first thing, a challenge to touch the physical devices, to have them on the premises in the lab, if it is a big unit, for example, and to have them as many as we would like we do with the web, where we can spin up a lot of VMs or a lot of operating systems and do testing in multiple environments. Those things would have some sort of sensors, which may be for temperature or humidity or gyro, GPS or motion sensors, all sort of sensors that need to be tested one way or another for accuracy and other parameters that need testing. Then we have more hardware, like the actuators. If the terms are not too familiar, it's just because really IoT is combining software as we know it with the hardware or electronics. Those with the background in electronics will probably understand, but you're free to go out there and do some research and get a bit of understanding of what these do. And now we've got the embedded systems, which are basically a sort of software, but that is embedded in a chip, like we see in our electronics devices. And the complexity here when it comes to testing is you have got this little black thing on a PC board. It has got lots of pins around there. When things go wrong, where do you think, how do we find where the problem is? How do we test such a complex black box? And it's literally a black box. That's probably what black box stands for. So you can see the complexity already over here of testing something like this and knowing where the problem might have been, and it requires a special equipment for this type of testing, not just Selenium. The second challenge I see is there is no UI, right? Again, I would ask you to raise the hand if when you see a console like this, like a black console with some little white characters that don't make sense, if you start to freak out like I do, or like I did when I started with the automation testing. This is just doesn't make sense for most of us as a tester. It just does not make sense. And that's what really IoT is for most of the cases. We don't have a UI, there's no interface as such. The devices are communicating between themselves. Before, as a user, we see the UI out there. There has been a lot of operation going on, and we need to test that middle tier between the device and the user interface. And that's quite a challenge. And I will come back to that in a bit. So this leads me to API testing. So for those, again, who are not familiar, API stands for Application Programmable or Programming Interface. And what is happening in the software industry, not necessarily in IoT, but in web application in general, developers are moving from the good old monolithic architecture where you will have the database communicating straight to the UI, to a more disconnected API systems where they kind of disconnect or decouple the UI from the backend, and all they do is just some HTTP request and brings a JSON or mainly a JSON that can be consumed by the UI, the front end system. That API needs to be tested in general. And the challenge is, as I said, there's no UI, so there's no click. It's not to be consumed by the average user. It is to be consumed by another front-end, mainly JavaScript program. So the question is, since the API, unless you probably go with the commercial tool, API testing, we need a bit of knowledge of the protocols, of coding itself. Shall we give this to developers, or shall we train testers to test APIs? And that's always a challenge we do have in our industry when we go we move from monolithic to APIs, and APIs need to be tested. How do we do this? Do we train a tester to a level where they can pick up the testing and do it, or do we leave that part to testers? And especially for those managers, test managers out there, it is quite a big challenge, because in one hand, we want to own our testing environment, but on the other hand, we don't necessarily have the skills already to do this type of testing. So we go back to developers. And that also leads to another question, where the first reason we need testers is that developers, they cannot test their own code. There may be a bit of bias when a developer tests their own code. So we want a third eye. And if we take back testing to development, we're just losing that partiality, if I would say. So that's the challenge with the API testing, which are basically the main communication these days between the backend and the front end generally. And that include things like web servers, HTTP protocols, SSL, TLS, web API, REST, and the many other terminology that are quite new to our testing environment, but we need to be familiar with, because they are coming and they are here to stay, and we need to jump in and roll our sleeves and do the testing. Network protocols, that's another thing we need to understand as testers. Now, I'm going to pause here and ask either Joel or someone on the channel if I'm going too fast.
No, you're actually going okay. I believe that you're covering it correctly, so don't worry.
Okay, great. The other challenge we see is the mobile devices. Mobile devices are basically used because in many instances, if you have got some IoT or some like camera, some people have got, they control the cameras with their devices, their mobile devices. But also we have them in many other instances where those things have got a short range of communication. So they communicate hardware and mainly communicate with the Bluetooth or Zigbee or some other short range infrared, short range communication. So they don't necessarily have that communication, that direct communication with the internet. So they use a smartphone or a tablet to communicate with the internet, or sometimes even to do the actual control. So you have got your IoT in your house, and you've got your app on the phone to do the control, of course, to serve as your interface. So mobile devices have got a lot of challenges. If any one of you is testing mobile coming from the web, you will see that there's a lot of like a challenge really testing mobile devices, starting from the architecture of mobile devices. It's quite very complex. Either Android or Apple, it's just very complex, from the Linux kernel to the libraries, the framework, and we are only really scratching the surface. Our app is just a part of a big ecosystem, but somehow it has to communicate with these other libraries to run, and we need to test those. And often we get confused whether the problem is with our app or with the underlying system itself or built-in libraries. So that's what I was saying. And the other thing is a very fragmented market. If you couldn't have all the devices on your table, it's a lot of manufacturers, it's a lot of operating systems, even if we consider the most popular one, iOS, Android, and the Windows phones. But again, within one operating system, we've got a lot of version. Like Android, you've got, I don't know, from gingerbread now to, I don't know, the N or O, now it's O. It's all of those, and eventually we'll be targeting at least 3 or more of that range of versions. So, and a lot of configurations as well. The form factor, you've got the small ones, 5-inch, 7-inch, 8-inch, phablet, it's all of that. number of things you have to worry about when you're testing mobile devices. And I touched mobile devices, I said, because they often serve as a gateway between the actual physical things and the internet or the user interface. The other challenge I see coming is the cloud. And again, as a testers, we often don't necessarily touch on the cloud, or you might be, depending on the size of your team or how you get organized. But now and then you might be asked to go to Amazon and start an instance. That's one thing. Or your data may be using some form of data analytics that is on the cloud or somehow. But in any case, the cloud is becoming part of the web architecture. And when things go wrong, it might be that things are going wrong on the cloud. And the challenge there is the cloud is not our own. It belongs to Microsoft or to Amazon or to Google. And we don't have necessarily the full access to the cloud to go there, create as many instances as we like, create as many users as we like, change the authentication as we like, as we do on our VMs to test whether a system can be broken if one configuration does change, or if we put 1,000 users, you can't just go there and create things as you like, as you do on your own PC or your own VM. So it also adding complexity, but also for those that are doing security testing, it is also increasing the attack surface area. So it's also adding more to the security and the stability of the system that need to be tested. Then we've got this evil one, the third-party libraries. We are in a hack culture at the moment, where if you wanted a system that can do anything, you just go on the net, you Google it, and you will most probably find someone who has been working on that one, a open source library out there, even a complete working example. So we are tempted as humans to just grab what is there, right? If it is there, it is working, what's the point of inventing the wheels? So this culture can infiltrate your company, and the developer goes online, grabs a piece of code or a full program, make it part of our production environment, and because it works, it just throws it to the tester for the tester to go to do their work. And the challenge is these libraries are not production ready. Most of the case, they may not be following some coding principles. They may not be safe. And as a testers, we need to be aware of those and be able to test properly when those libraries are being used that are not owned by our company. I have got an example here that I didn't put on a slide, but if any one of you has had, excuse me, more drink. Okay, excuse. So if anyone of you has used the Raspberry Pi, the little Raspberry Pi, if you go online and look for project, there are heaps, lots of projects on Raspberry Pi. But those projects, and that's the challenge with electronics, electronics has got its part where you need to follow some regulations depending on the country where you are. If it is a transmitter, for example, there are transmission protocols and the regulation. You cannot just spin up an FM radio and start to broadcast in your city 5 kilometers radius. You will see the regulators come to knock at your door because it is interfering with the other systems. And the worse, even if you have picked up a frequency that you think you're not interfering with anyone, there are some other things called harmonics where you think you are emitting on this frequency, but it's creating some other frequencies around there. And the point I want to make is if it is picked up from the internet, obviously the hacker did not go through the pain of killing those other frequencies. So it's probably transmitting more than one frequency, and that can be, you think it is working, which it is, but at the same time it's not working. It's doing something it shouldn't be doing. So as a testers, we need to be aware of those systems, not just that this thing is working, but is it also not doing things that it shouldn't be doing, especially when it comes to electronics. So that's challenge as well. We need to understand the legalities and the regulations around our systems if it does some form of communication, which actually it does because they are connected to the internet. So the other dimensions in IoT testing, as I mentioned, is security. I won't say much here. It's a lot of nowadays. If you subscribe to any feeds talking about IoT, it's all about security. You heard what happened in November last year, where some of the biggest US companies were down because some hacker just hacked some cameras, IP cameras. So security is really becoming something that IoT systems have to be aware of. And as a testers, we start to think of security as a part of our testing regime. Then the availability. These sensors will be anywhere on a plane, on a boat, at sea, in a bush, maybe monitoring some environments. They are everywhere. So it's not like your PC, you go check if your PC is on or off, or if it is your home, you can go check if your aircon is, the LED is beeping. But for these devices, they're out there in the wild, and it's always harder to know whether they will always be available. Available as in they are physically, available as in are they powered on, available as in are they transmitting, because they may be not transmitting because the environment is not good, because the area, it's very cloudy or anything else. And how do we simulate all those conditions as a testers? That's the question. Then the reliability, again, when you have got your sensor, you're reading your temperature, say a normal system reading the temperature, and you look at your temperature, you were expecting 30 degrees C and you see it's 100 degrees C. Now, is it 100 degrees C really, or is it not 100 degree? And if it is not, where is the problem? Is it the device? Is it the internet? Is it the UI? It's quite complex to know when the problems arise. So the reliability is something we need to test and to simulate. Then the safety. Safety and the security are two different things. As an example of safety, I would think of driverless cars. There is a security as in hacker coming and grabbing the data or fiddling with the system, but also safety as in when I sit in a driverless car, how safe do I feel? How intuitive is it gonna be when some other crazy car comes around and cut the line off? When the traffic light is off, is it going to think like a human and stop and wait? How do we coordinate those abnormal situations in a way that the equipment is safe to operate without the human interfering? Because that's the question with the IoT is we're trying to remove the human factor out of the system, and that raises safety issues. And how do we test those? That's always I'm asking questions at the moment. I'll probably come to answers later. Then the resilience, I think it goes with, well, resilience, again, as I said, they are in a very harsh environments and they're being pinged very often. They are processing multiple streams of data. They need to be strong enough to not break. And the compliance, I think I touched on this one. They have to comply with some regulations because our system might be interfering with the other systems out there. So I'm gonna roll through these slides because I think I went through the details about security and availability, where I mentioned that these devices are in the remote areas some of the time, sometimes on moving vehicles like planes and the drones and the cars or boats. And they normally have got low batteries because they are small-ish and they rely on wireless for communication. Safety again, one of the things I'm worried about is responsibility of the operator. I mean, as a human, we have got responsibilities when we do things. We think what can go wrong, and if it does, how am I going to suffer this? What are the consequences? The machine doesn't have that intelligence, that intuition yet, although there are some improvements with the IE and machine learning, but I guess we're not there yet. The other thing I'm thinking is a plane that doesn't have a pilot. I think it is really dangerous to decouple the fate of the driver or the pilot from that of the passengers, because one of the reasons I sit comfortably in a plane is that I know that the pilot has got a life he cares about, and it's got a family he wants to go to at the end of the flight. So he's really going to be careful that we get there safely. So his life is on the line, and that probably increases his awareness. But I'm afraid that if we give that to a robot, the robot's not going to be as careful as a human, because it doesn't have feelings and doesn't have a family. But yeah, that's safety part of things. And again, unattended devices and machinery, there's this human judgment that is missing when there is a critical circumstances, or when what we thought of didn't happen, because it's when we do the programming of things, we think of scenarios, right? We think of a scenario, maybe the light will go off. If you say a car, maybe the traffic lights will die off. We can think of what the car is gonna do, but there are things we cannot think in the program inside there. But if a human is driving, come to that situation and you know what to do right there. But if a machine was driving, it might not know what to do in that particular circumstances, and we expect some probably incidents because we don't have that human judgment. Okay, I talked of resilience. I'm probably not going to go there again. As I said, just physical environments are often harsh, and it's a lot of interference. So how do we test this? What do we do when it comes to IoTs? The first thing is really to strategize. I put a picture of a sort of a military meeting where they are thinking, what do we do now? There need to be some strategy. You need to sit down with the testing team, including actually developers, including if you've got some security people or IT people doing security, them as well, because it's going to touch on security since you just connect to the internet, and they come up with a testing strategy. One thing is, with the IoT, we still have the traditional testing. So most of IoTs we connect to the internet, we have a UI. So in the end of it all, we've got a user interface where the user can see the data, can control the device, can do some analytics, etc., etc. So that's one thing. The second thing is we have got the web, we have got integration and testing. So that won't go away. But the thing we need to do with IoT is testing in the wild, and that is whatever it is that you're doing, go out there and test it. Just don't rely on simulations. They have got their places, but often a question or an example I often give is, if you wanted to fly from Paris to Los Angeles and you got on a plane and the pilot goes, oh, welcome passengers, I've been doing simulations for the last 20 years, but this is the first time I'm flying a physical plane, let's go. I don't think I would go with him. So we need to actually test the thing in the wild. I mean, in the real environment, drive that car if it is driving, fly the drone if it is something to fly, go at sea if it was some devices to test at sea, etc., etc. So you need to do the physical thing. But at the same time, if you testing sensors on a ship like this, I don't think you will have enough lab or enough space in your workshop to have like 20 of these. So, or even really financially speaking, I don't think you would have a number of these for testing purposes, right? So there is a new paradigm, not necessarily new, but improving called service virtualization. Again, it's for us as testers to learn these things, but it's becoming popular now to use when we cannot have the actual physical devices because either it's not ready yet or it is too expensive to buy. So we can virtualize these systems and start testing without having the actual physical device. Then the security and the penetration testing, that's another thing we need to do. We can start by easy stuff like password strength. Again, go tomorrow or another day to your app, and you will see that sometimes you can, especially we say it's a testing environment, you can just put in T as a password and A as a username, and you get inside. That's bad habit, guys. The passwords at the moment, most of the systems still rely on passwords really, which is actually scary for security. But at least the least we can do is to make sure those passwords are strong and that policy is enforced in the with the developers. We can test cookies expiry. That's pretty easy to test. SQL injections, again, it's a very old thing, but we cannot pretend it's gone. So we need to test that, especially with the API. And the thing is, when it comes to data validation, often in the monolithic thing, validation could happen either at the back end or at the front end or both. So if the validation was at in the front end and we move from monolithic to API, the front end is not there anymore for validation. Well, it's there, but you still can fire HTTP requests and access the back end. So if there was no validation in the back end, it's easy to just inject some wrong data over there. So we need to be aware of those things and do that type of testing as well. And as I said, ultimately QA is going to be included in security, in the testing. It's going to include security testing pretty much in the near future if it hasn't yet. The other thing interesting is the user experience. Again, with the IoT, often we focus on, does the thing work? But the user experience is pretty much important, and we need to be aware of testing those user experiences, especially because of the complexity of the application. You will find that it might take you, I don't know, 20 minutes just to do the setup and a big book to read on how to install, which is good to help the user. But honestly, these days, people want just a plug and play. They just don't want to read a big book. They just don't want to go through setting up accounts and 20 minutes before they can use the app. It's still a challenge, but we need to be aware of those challenges and be able to input during production our user experience testing, experience, if I can say that, to tell the developers and whoever is involved, hey, this really isn't intuitive. This is just a pain in the backside. Something has to be changed. It has to be as simple as it could. And again, I'm not going to read probably this all together, but that was an article of a guy who bought something just to play with, and he wasn't happy because of the installation needed to do the whole process. And you can see, if you count 1, 2, 3, the fourth line, say you go 50-step process that we will now explain, to you in painstaking detail. I want to just highlight this painstaking detail that if your user is really expressing himself in those terms, your app is probably not going to be very popular. So we need to be aware of those. We'll probably have the slides online and you can read through these. Great. How are we doing on time? 8 minutes. Shall I stop there and get to answer a question?
If you just want to
Caleb?
wrap it up a little bit, remember that at the end of the session, you still have access to the Slack channels. But I think that one of the things that people are looking for, and I've been obviously going over the Slack in here, is to talk a little bit about the tools. If you have suggestions about more concrete things in order to, and again, just hovering over that, look for reliability and conditions and maybe simulators that you might be working with, specific just to point people in the right direction. I think that would be great.
Okay, great. Yeah. So yeah, I will fly through this one. What as a tester, as I said, we have to sort of upskill and understand these terminologies and the technologies around it. We also have the IoT, the future of IoT with the big data and analytics, artificial intelligence, all these things. Again, I will leave the slides there. So the tools here we have are more into automation. Is the one thing I would say is really very hard to test. So you have got your desktop, your web, your mobile, and your hardware. With the desktop, the web, and the mobile, it's normally the tools we have, mainly for the web and the mobile. Selenium in automation works well. Selenium for web and APM for your mobile applications. For the desktop, there seems to be no open source. If you're doing a desktop app, they're not very popular these days, but there seems to be no open source frameworks for this, but there are some other vendor tools like Ranorex that would do desktop, web, and the mobile at the same time if you like. But that's a commercial one. So the hardware integration tools that we use as a part of production, again, that depends if you are producing the actual hardware or if you're buying it off the shelf. If you're producing that, then LabVIEW is probably the oldest and the most popular tool to test electronics. So that's the tool. Again, service virtualization, and that is really when you don't have the actual device or the actual part of the system. You get these virtual environments from HP or some other vendors, and you use them as your part of the system that you don't have yet. And testing APIs, this is pretty critical, and it's not really too hard if you put your strength to it. So again, here we've got some vendor-based, UI-based, GUI actually based tools such as SOAP UI. I think it's the most popular at the moment. SOAP UI will do most of your API testing, and you probably can get away with the free version of these. But if you want to go further and do or you can do some quick tests with some HTTP client proxy, and this is not necessary in automation. Like Postman, it does pretty much a good job for you. You can fire up your request and they give it the actual parameters and you get a response, and you can check if the response is what you were expecting. But you can also write your code in your environment. If you are a .NET developer, REST Sharp is one library that you can use to do API testing, or REST Assured if you are a Java developer, and you can use your environment of choice. But really what it is, just send your HTTP request, get your response, and verify with the code if it is what you were expecting. So these are the tools for API testing in general. But mostly, if you're doing production with the hardware, You have to do your own custom built test rigs and test jigs, but mostly your electronics engineers will know what to do and they will help you around these. Yeah, that's all I have to say. What I would say is IoT is here to stay really, and it's expected to grow. So we need to get on board. The testing is really a blend of existing strategies with innovative ones, where you sometimes have to think out of the box because something new, innovative. We see companies like Uber, driverless cars, they have never been there before. So we need to be innovative at the same time. We need to upskill, definitely, and increase the cooperation with developers and DevOps and the other IT staff just to get a full understanding of what is happening out there, and include security penetration testing in our test plans. I think that's what I would say. In the end, I always tell people, keep calm, we will survive. Our jobs are not gonna go away. We just have to keep our feet standing. We just have to keep an eye on technology, and we have to keep upskilling. That's it from me. Thank you very much for everyone out there. Have a nice day, a nice evening, a nice morning, wherever you are in the world. Cheers.
Bede, thank you very much for the session. I think that as an overview of the challenges and really the new stuff that we need to start getting acquainted when trying to look into the IoT paradigm of testing, then it was a great overview and a great introduction into it for many of us, I'm sure. We are right now just at the top of the hour, which means that we're entering a break. There are a number of questions that have been asked on the Slack channel. It would be great if you can just go over there. And again, guys, if you continue having questions, Bede, I'm sure that he will be over there and we will be sharing these videos. So guys, thank you very much. Bede, thank you very much for waking up early and helping us with this great presentation.
Thanks,
And
Joy.
remember, we have the last session coming up, so we have 15 minutes, and then we will be doing the last keynote and the wrap up for this online TestConf. So guys, let's go on a short break, and we will be right back. Thank you very much, Bede.
Okay, cheers.